Hello, my name is Elliot Kyung-ha Jung. The given projects of the assignment are I put a screenshot of what I was working on and put it on the video. For the voice of the video explanation part, I used Clova dubbing developed by Naver Company, Limited, instead of my Korean-American voice. Single-cycle gas turbine power plants generate electricity by using natural gas and compressed air. Air is drawn from the surroundings, compressed, and fed into the combustion chamber of the gas turbine. For single-cycle gas turbines, much of the energy is wasted as hot exhaust, achieving an energy conversion efficiency of 35% at best. Combined cycle power plants are power generation plants that use both gas and steam turbines together to generate electricity. To develop a predictive model to predict full load power output, evaluate the performance of the model. Multiple regression is an extension of simple linear regression. It is a modeling method that uses multiple predictors or independent variables to predict a target, variable, or outcome. The general form of multiple regression: exploratory data analysis. Develop the model. Evaluate the model. Select the best model. First, we will load the data after importing all the Python libraries that we would need. We can see that this data set consists of 5 numerical variables. There are no missing values across all the variables, and the data type is a float point number. This is certainly good news, as we have a clean data set. Next, we look at the distribution of the data set. The data set consists of 4 hourly average variables, or features, and the target variable, which is the output power. Next, that we have had a feel of our data set, we need to determine which features will help us predict the output power, because the goal of regression is to create a mathematical model from the features to predict the target variable. We need to ensure that we select features that have a strong correlation with the target. A correlation matrix would be useful in doing this. A correlation matrix is a structured approach to ranking the importance of predictors or input variables on the output. To do this, we plot the heat map of the correlation matrix using Seaborn. Correlation is measured on a scale of -1 to 1. -1 means complete negative correlation, and 1 means complete positive correlation. O means no correlation at all. When visualized, we can easily see that there is a distinctive pattern seen on at and V in relation to PE. 2. Develop the model. What we will do here is to develop several regression models using different machine learning algorithms and different combinations of features. First, let's create 4 different combinations of features and train our model with the 3 regression algorithms. Model 1, we select only et as the predictor. Model 2, we select AD and V as the predictors. Model 3, we select ADV and RH as the predictors. Model 4, we select ATV, AP and RH as the predictors. Our target variable is y. That we have finished with our feature selection, it is time to train our ML model. Training the model. Before we actually train our machine learning model, we need to first split our data into a training and test set. Finally, we have gotten to the exciting part where we implement the regression algorithm and develop our predictive model. Now that we have trained our model on our training set, we are ready to make predictions on our test set. The code implementation for decision tree regression and random forest regression can be seen below. For decision tree regression, for predictions, for random forest regression, for predictions. A random forest is an ensemble algorithm that fits many decision trees on various subsamples of the dataset. Predictions are made by averaging the predictions of each decision tree. This improves the predictive accuracy and controls over fitting. 3. Performance evaluation. Whenever a machine learning model is developed, it is important that its performance is evaluated to ensure it is yielding useful outputs and not overfitting. For regression problems, there are 3 key performance metrics that are used to assess how well your model is performing. First, root mean squared error measures the average error performed by the model in predicting the outcome for an observation. Second, R squared, it means how much of the variation in the target variable that can be explained by the set of features used in training the model. The higher the R squared score, the better. Third, Mean absolute error measures how far predicted values are away from the actual values. The lower the may value, the better. Table showing evaluation metrics for the learning algorithms. 4. Validation and select best model. Now that we have evaluated all our models, we can see that the random forest regression algorithm with model 4 gave us the best performance. The R squared is 9,644. Similarly, it yields the lowest RMSE of 3.1891. We can conclude that from our results that model 4 with random forest regression should be selected. 5. Conclusion. At the beginning of this report, we set out to develop a predictive model for full load output power. Based on the dataset provided, we explored the dataset to find out if we had missing values or other problems. Then played around with 4 features subset selections on 3 different machine learning regression algorithms. We were able to discover that using a complete set of parameters or features on the random forest regression algorithm yielded the best results. We obtained an R squared of 9,644 and RMSE of 3.1891. Thank you very much for reviewing the assignment.